Welcome to our Junior Olympiad series. In this video, our grade 6 student Shravan is exploring Euler's rule in polyhedrons. Shravan has a simple motive: learn a new concept, see how it can be applied in different ways, and explore it further. He is already ahead of the competition. If you want to compete, just as Shravan is doing, you can always join my classes. Get ready for the future. We will also explore interior and exterior angles of the polygons. Watch this video and learn. Be ready for the competition. Hi Shravan, how are you doing?
Hi, sir. I'm doing very good, sir.
Okay, so today what do you want to learn?
I want to have a question.
Yeah.
I'll just read that question out.
Yeah, sure.
And then you can just note it down in the whiteboard, sir.
Okay, you can share the screen. You can share the screen and then I'll answer your question, okay? You can share the screen.
1 second.
Yeah. Great. Which question? Find the number of faces, edges, and vertices of the following, right? First is triangular prism. Okay, let me annotate and then we'll research. So you want to understand triangular prism. We're looking into faces, edges, and vertices. Now, to solve such questions, you should have a clear view of how does a triangular prism look like. So let me sketch one and then we'll work it out. Is it okay?
Okay.
So to make a prism, remember that its top and bottom will have exactly same face, right? So we have two triangles shown as in this figure. Now, to make it a prism, we will join the sides, right? So assume all these are absolutely straight lines, right? These straight lines are called edges, correct? So now, first we have to figure out the faces. Can you tell me which are the faces for this particular triangular prism?
There are 1 second. One. No, what did you ask? Can you repeat?
Faces, number of faces.
Okay, faces.
Yeah.
There are two rectangle faces.
Two triangular faces, top and bottom. And how many rectangular faces?
One.
No, one.
Oh, no, three.
Three, right. So there are three rectangular faces. Is this clear to you? So in all, yes, there are 5 faces. So we have 5 faces. Is that okay? Now let's count the edges. Edges are these lines, right? These lines are the edges. We have 3 edges for 3 triangles in the top and bottom. So that makes it 6 and then 3 vertical. So that makes it 9, right? So we have 9 edges. Is that clear to you?
Yeah.
How about the vertices? The point where the 2 edges meet is called vertex. And so the vertices, plural of vertex, will be these. How many are there? 3 corners of the triangle in the top and 3 on the bottom. So that makes it 6. Is that clear to you?
Yes, clear, sir.
So we get 5 faces, 9 edges, and 6 vertices. Do you know how they are related? How do you know this answer is correct? Shravan.
What?
How do you know this
answer?
Yeah,
that's what I'm thinking.
Okay. Check this out. If I add 5 and 6, what do I get? And if I subtract 9, what do I get? Try to work out this. Number of faces plus number of vertices minus edges is what? Is it equal to 2? If it is equal to 2, then it is correct.
I recorded.
So what you said? It is which formula?
Eulers.
Euler's formula. You learned it, right? So 5
Yeah,
plus
I learned it
is
from you. I
you
recorded.
learned from me in previous classes, right? So that is Euler's formula. Good job. So Euler's formula for all these shapes works. And we know that the number of faces plus number of vertices minus the edges is always 2. And as we see here, right? Now is this absolutely clear to you?
Yes, sir.
Now let's take the next example. So let me clear the screen now. The next
Yeah,
shape for
sir.
you is hexagonal prism, right? So let me sketch hexagonal prism for you. So hexagon means 6 sides, right? So we have this prism, 6 sides. So I'm making a rough sketch here. And the second one will come at the bottom. So 2, 1 top, 1 bottom. Both should be exactly same, okay? So trying to make one same. Okay. Okay, so now let me make one here. So these are top and bottom. And then we are going to connect the vertices. And as we connect, we kind of make, right?
Yeah.
Now tell me, how many faces are there?
8.
Yes. So there are 8 faces. We have 2 hexagonal faces, right?
Yeah.
And 6 rectangular faces, correct?
Yeah.
So 8 in all. How many edges? How many edges?
2.
No, edges are these sides, right? So 6 at the bottom, 6 on the top, and 6 vertical, joining them. Do you see that?
Oh,
So it is
sorry.
6 plus 6 plus 6, which is 18, right?
Yeah.
Perfect. How many vertices?
Uh,
How many vertices? Hexagon,
12.
hexagon. 6 and 6, 12. Right. That is correct. Now, can you check Euler's formula? Does it work?
Yeah.
So what do you get? So 12 plus
18 minus
8.
8.
So faces plus edges, right? So 12 plus 8, what is it? Sorry. Minus edges. So 8 plus 12 minus 18, right? So 20 minus 18 is 2. So it works, correct?
Yeah.
So basically, you have to check your formula, which is faces plus vertices minus edges should be equal to 2. Is this clear to you?
Yes, sir.
Okay, so you should learn how do we sketch these prisms, how do we sketch each and every face, and how do we count faces, edges, and vertices, and then check our result using Euler's formula. Is that okay? So we're done with prisms. The next question here is triangular pyramid. Can you tell me, for a triangular pyramid, how many faces will be there, how many edges will be there, and how many vertices? Can you sketch a triangular pyramid? Okay, everything is back. Now tell me, in this triangular pyramid, you understand this is a triangular pyramid?
Yes, sir.
How many faces are there? These are all triangles you see?
Yeah.
Yes. So one at the bottom and vertically there are 3, right? So total number of faces are 4 and all are triangles, correct? How about the number of edges? Can you tell me? How many edges are there? 3 in the bottom and 3 vertical. So it is 3 plus 3, which is 6. And how many vertices?
4.
4. And now, do you get the relation?
Yeah, we just apply the Euler's formula.
What is Euler's formula?
Edges minus faces is equal to vertices. Vertices, edges minus faces is equal to 2. Which proves that we have calculated the vertices properly.
So add these two. So we have faces plus vertices minus the edges is equals to 2. As you can see, number of faces are 4 and vertices is also 4 minus edges is 2. So that is correct. And that is how we are going to do it. Correct?
Yeah.
The next one here is hexagonal pyramid. Now, for hexagonal pyramid, try to tell me number of edges, faces, and vertices. Do it in a notebook and then tell me the answer. I'm sketching one for you here.
Yeah, I'm just doing.
We'll begin with the faces. Yes, vertices, edges. How many faces? When hexagonal, one is the base, right? And because it is 6, there will be 6 vertical triangles. Do you see that? So
Yeah.
faces will be 1 plus 6, which is 7. So that way it becomes easier for us to calculate. How many vertices? 6 at the base plus 1, right?
Yeah.
So always 1 on the top and 6 on the base. Vertices is also 7. How many edges? 6 on the base and 6 connecting, right? So 6 plus 6, which is 12. Correct?
Yeah.
And now you can verify that the sum of first two, which is faces plus vertices minus the edges, is how much? 7 plus 7 minus 12 is equal to 2. And therefore, the Euler's formula worked. And we know our answer is correct. Do you see that?
Yeah.
So can you summarize how did we find or how did we solve this particular question?
We used Euler's formula and
To check. Euler's formula to check, right?
Yeah.
Perfect.
And to draw the prism and to solve this question.
Correct. Can you please read question number 5 now? I'm erasing the screen. Can you please read question number 5?
Yeah. What is a tetrahedron? Draw it.
Right. Tell me what is a tetrahedron?
For what?
Tetrahedron is triangular pyramid. That is the triangular pyramid. This is the simplest 3D shape. Do you see that? That is tetrahedron. Very important shape. You will learn that it is also a form of water molecules. We will talk about it later. But anyway, it forms some compounds. Very, very important shape, tetrahedron. Now tell me. So you know the answer now? What is a tetrahedron? It is a, what is it? How will you explain it? What is it?
Triangle. It's made of triangles. And
Triangular pyramid.
Yeah, it looks like a pyramid, but I was not sure, so I didn't tell it.
Okay, good. Now let's answer the next question, which is question number 6. Give the names of two things which have the following shapes. Cuboid. Give me two examples. Cone. Give me two examples. Cuboid. Give me two examples. Fast. Cone. Give me two examples.
Yeah, I'm doing cylinder
No, cylinder is
and the
different.
birthday cone.
Yeah, birthday cone. Yeah, birthday cone. Ice cream cone.
Yeah, and cuboid I've never I don't know. I'm not sure.
How
Cuboid.
about ice cube?
Yeah, ice cube and book. What about a big and lengthy textbook?
Cuboid has all equal sides, correct? So that is a
Yeah,
cuboid. You can have a dice.
yeah.
How about this?
I
So
thought dice was a cube. I thought dice was a cube.
cuboid. Okay. So
Okay.
yeah. So that becomes a square-based prism, right? So that is the cuboid which we have done. Now, next question, please. Give reasons. Question number 7. A square can be thought of as a special rectangle. Tell me.
Yeah, because there are some common properties between square and rectangle.
So, what makes it special rectangle?
Because they both at least have one equal side
All
and
equal sides, right? Instead of having two sets of equal sides, rectangle with all equal sides is a square. You get the idea, right?
yeah.
Okay, next question. 7b. Squares, rectangles, parallelograms, trapezoids are all quadrilaterals, right? Give reason why.
Yeah.
Tell me why. Quadrilaterals means four-sided figures.
Yeah, trapezium four-sided, parallelogram four-sided.
2D, two-dimensional, right? So these are
Yeah.
four-sided figures, right? All edges straight, correct? They meet at vertices. These are quadrilaterals, right? So that is
Yeah.
common between them, right? Now, question number 8.
Yeah.
Write the sum of interior angles of a heptagon. What is heptagon? Heptagon is seven-sided figure.
Seven-sided polygon.
Seven-sided polygon. So if there are 7 sides, then how many triangles will be formed? How do you find heptagon? You have to find sum of interior angles of a heptagon. How will you find?
The sum of exterior angles is 360.
Let me start like this.
Hello?
Sum of interior angles you have to give me, right?
Yeah.
Sum of interior, how will you do? 1, 2, 3, 4, 5, 6, and 1, 7, right? Okay. So if
Yeah.
I connect it with the center, how many triangles do you get? 7. 1, 2, 3, 4, 5, 6, 7. Do you see that? So 7 into
Yeah.
180, all the sum, right? And in the center, you have 360, right? So minus 360 is your answer, correct?
Yeah.
Heptagon. So how much? Calculate and tell me. 7 times 8, 56, 5. 7 times 1, 7, and 5, 12. So 1260 minus 360, right? So you get what? 900. Sum of interior angles. Correct?
Yeah, sir.
Do you have a formula to calculate sum of interior angles? Yes, you have, right?
Yeah.
What is the formula?
180 times n minus 2. Number
Okay.
minus 2.
So what do you get here? 180 times 7 minus 2 is 5,
Uh,
right? So we have 180 times
yeah.
5. How much do you get? 900 degrees. Do you see that same answer?
Yes,
So
sir.
you could use a formula. Which is 180
Okay.
times n minus 2. It is the sum of interior angles, or you could make a figure and figure it out. When I say sum of interior angles, then the angle in the center is also included. So we need to exclude it. So, and then that gives you the solution in one part. Is it okay? The other solution which we got is using the formula. Is this correct? Right?
Yes, sir.
Okay, we'll do the last question now. And this time I saw another question here, which is question number 3. Can you please read question number 3?
Find the measure of an interior angle of a regular polygon of 20 sides.
Only interior angle of 20-sided polygon. Tell me, how will you find this?
I can't calculate interior angle, so you will find sum of exterior angle, which is 360. That is the
Okay,
formula.
good job. So we'll find the exterior angle. So find exterior angle.
And just taught me this just
Because
just few days
sum
ago.
is 360, so we'll divide by 20, which gives us how much? 18 degrees, correct?
Yeah,
So the interior angle is how much?
180
180
degrees.
degrees minus 18 degrees, correct?
Yes, sir.
Because a linear pair, a straight line, is 180 degrees, right? We know. So how much
Yeah.
do you get?
126. Sorry, 162.
Do you understand? So this is the fastest way of calculating each interior angle. The alternate way could have been, you could use some formula, right? So there
Yeah.
are 20 sides. So 20 minus 2 times 180, right? But divided by 20 will give you each angle. Is it okay?
Okay.
So that will give you, right? So you can do that. So basically we have 180 times 18 divided by 20, right? So you could simplify this and get your answer. 20 cancels and this goes 9 times. So 9 times 118, right? So basically 10 times 18 minus 18. Do you see that? You
Yeah.
get the same thing. You see that? So this is how you could do this particular question. So in a way, we have answered this block of questions for you, and you now understand about the two-dimensional figures and the three-dimensional figures, right? Polygons and polyhedrons.
Yeah.
Okay, so you have both the things. You learned Euler's formula also, and to verify your results. And you also worked on two-dimensional figures to figure out interior angles, some total interior angles, exterior angles, and total of exterior angles. Do you have any doubts?
No, sir.
Okay, so we'll stop sharing and we'll conclude the class. Yes. Shravan, can you summarize what did you learn while solving your worksheet today?
Yeah, this worksheet was interesting. Just living a bit seniorly, like senior level. Other than the back school worksheets which I used to receive some 6 months ago,
Yes.
and even now, this worksheet is some shut talk. Yeah, but I liked it.
You liked it. Now,
And
Shravan.
we talked about Euler's rule.
Yes.
And sum of exterior angles is 130, 360.
Yes.
And sum of interior angle is 180.
Times
And
n minus 2.
Yeah, time 10 minus 2.
N minus
Yeah.
N minus 2. Yes. So, Shravan, you are a grade 6 student, and for you to know all this, which normally students will learn in grade 8 or 9, is very good. So, I really appreciate the way you picked it up and you still remember some of the concepts which we talked about earlier. That's great. So, we'll end our class today here, and next time we'll take another challenging question for a grade 6 student. Is that okay?
Okay, sir. Okay, sir.
Then. All the best. See you next time.
Yes, sir. So can you
Bye.
stop the... Bye.